Hello everyone, I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about grounding in electrical wiring and safety. Okay, I have a question for you all. What do you mean by grounding? Why do we need grounding in electrical wiring and safety? Okay, first, what do you mean by grounding? Actually, grounding in US or earthing in UK, it is a process of connecting electrical systems like our home appliances and metal enclosures to ground. Actually, this ground it refers to the physical connection to earth which act as a reference point and also a return path for current. We know that very well. Here, grounding can be implemented with the help of electrodes. The main purpose of grounding is provide electrical resistance, a kind of low resistance path for electricity to flow. See here, whenever we are taking a typical grounding system, it has two parts. One is individual branch circuit, which consists of wire. Wire means ground wire. And the another one is grounding system. It consists of large copper wire. It is known as grounding electrode conductor. That is connected to ground rod, which is buried into earth. Okay. And types of grounding, we have so many types. Particularly, we have two types. One is low voltage systems, another one is high voltage systems. Actually, we have some grounding arrangements based on government rules. Here we have TN, TT, RIT. Here T, which is known as direct connection to earth, and I is no connection with earth. And another thing, the second letter, first letter which indicates direct connection to earth and I is no connection to earth. And in the second letter, T means local earth connection and N means electricity supplier provides the earth connection. When high voltage systems, the power generation stations, substations, they are using high voltage systems. Whenever we are preferring low voltage systems, like our home appliances, our small industries, we prefer the grounding arrangements like TN, TT, or IT. Okay, and types of low voltage grounding, we have TN grounding, TT grounding, and IT grounding. And thus TN grounding, we have TNS, TNC, TNCS. Here TNS means the ground and neutral conductors are separate and are connected at the transformer side. TNC means ground and neutral conductors are same. TNCS means separate ground and neutral conductors but only near the customer side, which means our home side, our house side. And TT grounding, and this type of grounding, the grounding at the transformer and at the consumer side are independent, like star point. These 2 points have no connection. And when IT grounding, there is no grounding at the transformer, but there is a connection of grounding using a ground electrode at the consumer point. Mainly three types of low voltage grounding are preferred: TN, TT and IT. And this TN we have types like TNC, TNS and TNCS. See, the low voltage grounding types. First one, see here, the TNC system. Direct connection to earth is T, I is isolated, N is neutral, S is separate and C for combined. See here, here we have PEN, a new term, protective earth plus neutral. C, first one is a perfect example for TNC system, either single phase or three phase. Single phase means 230 volt or three phase means up to 400 volt we are using it. And TNCS system, and third one is TNS system, TT system and IT system. Based on the consumer needs and applications, we prefer either TNC, TNCS, TNS, TT or IT system. See, types of high voltage grounding, we have three types actually: underground systems, resistance grounded systems and solidly grounded systems. See the example. Here we have three phase from power company and which is fed into transformer. We have phases are lines, current carrying lines, and also we have neutral line which is represented in blue color. And here the line carrying wire which is line are phase and neutral is connected with our home appliances. Okay. Ungrounded system. First one is ungrounded system. An ungrounded system is not really ungrounded. Electrically, the system is connected to ground, but that is a capacitance grounded system. In it, ungrounded means because of its convention and uses doesn't use any direct physical connection between any of the power lines of the ground. See, the probe are target capacitance and current flow which is buried into earth through capacitance. Target are ground capacitance. C. Resistance grounded system. Resistance grounding is when a connection between neutral line and the ground through a resistor is connected. Here, this resistor is used to limit the fault current through your neutral line. C. If voltage doesn't change, then the current is dependent on the size of the resistor according to our Ohm's law. Ohm's law is V equal to IR. See the diagram. Here we are using resistance before the grounding connection. And what are the advantages of resistance grounding? It reduces the current and reduces the over voltage, and also it reduces the heat, and also which keeps the wear and tear of electrical system to a minimum level. Here it maintains a high safety, which is a little bit costly to repair. This reduced current also reduces the risk of shock and arc flash or blast hazards in electrical wiring. See, types of resistive grounding. We have high resistance grounding and low resistance grounding. See the diagram, which is our practical high and low resistive grounding systems. See the high resistive grounding. It is typically used to limit the ground fault current between 0 to less than 10 amps. Here, which is the low current, it will typically not trip your protective devices during a single line to ground fault. This low ground fault current also means that just like an ungrounded system, it can continue to operate the system on a single line to ground fault. That's it. Okay, and low resistive grounding, here it limits the current between 100 to 1000 amps. It is typically used in big generators or motors. See the diagram. Here we have load and we have ground neutral lines, and also we have three phase lines, phase A, B and C. It resists the flow of current in the range of 100 to 1000 amps. Typically, it is used in where big generators and motors are used. Here, one more thing, this low resistance grounding also reduces over voltage, and it is used in medium voltage systems of 15 kilovolt or less. See, the last one is solid grounding. Actually, without any sort of resistance in the way, solid grounding is connected. Here, the ground is typically connected to a system at a neutral point, like neutral terminal of a generator or transformer. It has two main uses. One is systems with 600 volt or less, solid grounding can be used, and which is used to maintain without fault circuit. For the systems used less than 600 volt. If in the systems with 15 kilovolt or greater, solid grounding can be used if high ground fault currents are desirable of reasons such as quick current fault detection. It is used in both the way. For 600 volt or less, also the systems with 15 kilovolt or greater. Thank you. I think we all get a clear understanding about why grounding is preferred in wiring safety and wiring safety in electrical systems. Thank you.